So this is the free version. You can go and download this, FTK Imager. FTK, the full thing, is much more expensive than free. So I'm going to go ahead and grab an image. Oh, sorry. Here we go.
Is there a limit to how large of an image you can mount?
I think there's a limit. They said I don't want to say it's like 20 megabytes or something like that.
On the free version, so it may be limited on the free version. I'm not positive, to be honest. I actually have a 4 gig. This file here is a 4 gig VMDK. Yeah, it's a 4 gig VMDK, and there's no issues with it. So I don't know what the maximum is.
So is this the free version or the paid?
This is free.
Okay.
Yeah, I just downloaded this, and so I'm going to go ahead and this just happens to be a DD file, not a VMDK. So you can go out. There's a NIST website that has some forensic DD files set up, so you can practice file carving and such, and that's exactly where I got this. If you click on this, you can notice it says unrecognized file system right here, mainly because it's not really a file system. It's not pulled straight off of a Windows or a Linux machine. I'll go ahead and mount that other image. And this is, like I said, a VMDK. This is a VMware VMDK from Windows 7 disk. And you can see it just says Workstation 1. There's one partition, and there's also the unpartitioned space, right, that you can go look at if you want to. Here's unallocated space, and here's that space. Now in the partition, under root, now you can start to see that this must be a Windows, because here you see the documents and settings, program files, right, and obviously the word Windows. So that gives you a feel for what this looks like when you mount a VMDK file. And should you choose to do a physical drive, in this case, this will let you do this particular drive, and then this also has a side or a extra data drive called target. So there's the physical drive, what that looks like when you mount that. This knows it's NTFS, but it's also just a data drive called target, and it's got some information in here similar to a Windows file system. Okay, so we'll take a look here. Let me open up.
Where did you say you got the DD?
A NIST website.
NIST.
If you look up forensic practice disks or something like that, practice information or something like that in Google, there is a NIST site that you can pull that down from. Okay, so I'm going to cheat and grab this header, the JPEG header from this file here. And what I'm going to do is start here, right-click, and do a find. I want to switch it to binary, since I know I'm using hex actually, but binary. And there's the header, the common header of FFD8, FFE0. And we'll go ahead and do a find.
That's still your Windows, isn't it?
Yeah, that's.
That's in the physical drive, huh?
That's pretty fast.
Yeah.
Considering that's
Sorry
4
about
gigs.
Yeah, that is actually not too bad. Sorry about that. Forgot to select this again. So these are already left from the previous. So here it finds it at this location. And then we also know that, as I was mentioning before, FFD9 is a footer for a JPEG, depending on the version of that format. So what we can do is we can start here, do a find and do a FFD9. Okay, and that's the first place. So sometimes this happens in data, and it's not necessarily the end of your particular file. Sometimes you'll want to carve it and see, but it just so happens that somebody else has carved it already. And we go down here. And now you'll notice that these are zeros, and sometimes they call that RAM slack, where the operating system knows it's the end of a file and it's in a particular cluster with however much left, that slack space that's left in a cluster, and they'll load it up with zeros. But this happens to be from that NIST site, so they probably just ended it here. And what you'll want to do is document these addresses, the 1B, I can't highlight this, sorry. Can you see this right here next to the 1BD7920? And then you'll want the
Start of it.
right, the beginning of it as well. And it just so happens that I have those start addresses and end addresses. So even though I cheated and I have the value, what you'll want to do in order to use this, it doesn't, unfortunately, it's hard to just highlight and pull it down. You'll want to figure out to copy and to cut and paste it, and to highlight that area, you'll want to figure out an offset. So you change that to hex, and you use the last address or the footer address of 1BD7920 and subtract the header address of 1BC8C0. 1BC8C000. Okay? And that's the ED20 is the offset that I'll be using. So copy that. Close the calculator. Let's go ahead and start up here. What I can do is just start from the very top, do the find for the 8 F 0. Oops. Sorry. Okay, and so there's the beginning. What you do is you'll put your cursor here, and you'll do go to offset, or I'm sorry, set selection length, and you'll want this to be in hex, and that will be the ED 20. Boom. Now you highlight that, and you do a save selection. All right, and we'll just do test.jpg. We save that file. We come to our images, and there you have it.
Oh.
You've carved out a nice little picture of Moscow, Idaho. So this was obviously really straightforward, right? This had exactly where it started, exactly where it ended. Really easy to find. When you're doing actual incident response, not quite this easy. Part of this may have been destroyed or overwritten. So some of it may be much more difficult, but this is just a simple example of some data carving using this. Anybody have any questions?
What does the node look like, an FTK, for the physical drive?
I'm sorry?
What does the node look like if you drop it down in the software?
You're talking
An FTK?
So what is the physical drive?
What does that look like if you open it up?
Okay. So in this case, this is just a separate data partition, so to speak, which is actually, if you look here, this is just the Z drive. The target is what I is what I did. So that's this, and the only thing I happened to have in it was an installation of Notepad++, so it's not very exciting.
So if you do a search for the executable, you should be able to find that, like the string for executable. You should find that on that target, right?
Yes. Yep. But at the same time, there might be more than one executable in there, so then you'll have to kind of go do some carving and figure out which one's which. Yep. So.
But you still might be able to get a good idea what type of disk that is.
Yep.
Just by looking at it, because we
Yep.
saw the recycle bin.
Oh, exactly. Yep. That's definitely some good indicators as to what those look like.
Is there anything that does like your carving for you?
I'm not sure if there's some automated carving tools or not. I'm guessing there would be, because if you know the headers and footers, maybe you can just tell it, go get all JPEGs that, or PNGs or whatever type of files. I imagine there are, but I think it's just, I guess that's a good way to parse through some of that to get like your initial, yeah, we definitely found these.
Instead of searching through each one, you just be like, give me them all.
Yep. That would be good. I do not know of any in particular, but I would guess that would be the case. If you have the beginning and the ending and just pulling that out of a disk, I think would not be an issue.
It's like the tools like, I think ESIS lets you remove like undelete or like pull up undeleted files, and it marks them what they are. It probably does the same type of thing in the background for you, saying, okay, here's the start of a JPEG and here's an end of a JPEG, so this is probably a JPEG file. And it kind of gives you the probability whether it's damaged or not too, so it's interesting.
Okay, so that was a file analysis demonstration.